On this one, it gives us a table of numbers that are supposed to represent the total years of formal education for 30 employees at a bank. We're going to use this data here to create a frequency, relative frequency, and cumulative frequency table, and then make a bar graph from there. So again, frequency means we need to go through and count up the number of values. So for instance, the number of zeros. There are how many zeros here in this case? We can count up 5 of them. So we say the frequency is 5. For 1, there are a total of 8 of those. For 2, there are also a total of 8 of those. There are 3 3s, there are 2 4s, and there are 4 5s. To do relative frequency, we have to divide by the total. So it said here there are 30 total. So we'll go through and do like 5 divided by 30, which is equal to approximately, rounded off to 0.17 or 17%. 8 divided by 30 is approximately 0.27 or 27%. Same for the next one. And then 3 divided by 30 is equal to 0.10 or 10%. 2 divided by 30 is approximately 0.07 or 7%. And then 4 divided by 30 is approximately 0.13 or 13%. Cumulative frequencies we find by going through and adding those frequencies together, starting with just the first frequency of 5, and then doing that frequency plus the next one, so 5 plus 8 to get 13. And then we add the next frequency to that to get 21, and then 21 plus 3 to get 24, plus 2 to get 26, and plus 4 to get 30. On this one it says we're going to create a frequency table with a bin size or bin width, class width of 5. We don't have a lot of temperatures here, but they're supposedly the hottest temperatures for 7 cities in North America. There's not a one set in stone way of setting up your bins, so as long as we're using the same width, then we can kind of start out in different places. So for instance, if I go 101 and then bin width of 5, I'll go to 106. Then the next one would be 107 to 112, then 113 to 118. And then we count the number of values that fall within each of those bins. So for instance, 103, 103, and 102 would be counted under the 101 to 106 bin, so that has a frequency of 3. For 107 to 112, there's only one value that falls inside there, and then there are 3 that fall within the final one. Now to set up a histogram here, we have to set up the values along the horizontal axis, so starting from like 101 to 106 to 112, and then I'm actually going to make it look just slightly different here at the end. I'm going to put 119 here at the end, just to have the understanding of what numbers fall inside each of these areas on the horizontal axis. So this first part would be for counting up the numbers between 101 to 106, and then the second would be the numbers from 107 to 112, and then the next one would be the numbers from 112 to 118. And so to represent this, the frequencies, the first bar had a frequency of 3, or that bin has a frequency of 3, so we'll draw our bar going up to 3. And then the second bar only has a frequency corresponding to 1, so we'll just make that beside the first one, going up to 1, and then the last one will go all the way up to 3. In this question, we're looking at what we call the stem and leaf display of the data. So the stem and leaf plot was to break down the numbers according to like the digits place. So in this case, the digit you see in the first column would be the tens place, and then all the digits next to the dividing line would be all the numbers from the ones place. So we're listing out all the values in the data set broken down by their digits from tens and ones. So the first question is, what's the highest number of hours worked in the 50s? Well, in the 50s, we have two values. We have 5 followed by 4 and 5 followed by 6. So the biggest of those two numbers would be 56. For the next question, what's the greatest number of hours worked overall? Well, that would be the same as the last one. Also, 56 is the largest out of everything here, because all the other numbers would be either 40, 30, or 20 something. And then the last one is how many responses fell in the 30s. Well, in the 30s, we look here and we count up how many different numbers we see. We see like 31, 32, and there's several of those. There's also a 35 and a 36 and a 36. So there'll be how many here? There are 8 total. So that'll be however many numbers were in the 30s here. On this one it says, if there are 17,000 students at a college, how many chose drama? Well, the pie chart shows us how many percent of the total, in this case 27% of the total of 17,000. So all we have to do is take the 27% of 17,000, or 0.27 times 17,000, which is equal to 4,590. On this one it says find the following values. We're going to create the mean, median, mode, and sample standard deviation, the 5-number summary, the interquartile range, identify any outliers, and then finally a box plot. Okay, let's start with the mean. Now they do specify sample, so we need to think about sample mean. Basically the same calculation we might go through for a population mean, but the idea is, did we use the X bar notation for sample mean? That's the sum of all the values divided by the number of values in total. So we add up all the numbers together divided by the total number of values, and there are 9 values here. So if we do that calculation, we come out with approximately, rounded to the nearest tenth, 54.9. Now the mode is the number that shows up the most in the list of values. Any that shows up more than once could be considered here, and in this case there's only one number that shows up more than once, and that's 73. Now for the median, we're going to need to put the numbers in order first. So that looks something like this. And then to get the median, we have to look at the middle. Is there one number in the middle? In this case, there is. The median in this case is 54. Now for the other parts where it said the 5-number summary, to do the 5-number summary, we have to list out the low, the high, and then the lower quartile and the upper quartile. Now the lower quartile is the median of the lower half of the data values. So to get the lower quartile, in this case we have to take the 2 middle numbers in the lower half and add them and divide by 2. So 30 plus 35 divided by 2 gives us 32.5. Sometimes they refer to that as Q1 for the lower quartile. The upper quartile is situated in the middle of the upper half of the numbers. So in this case, we have to look at the 2 numbers in the middle. Notice how the median has split them into 2 different halves, the lower half and the upper half. So we're going to have to add these 2 numbers together, divide by 2, and Q3, the upper quartile in this case, is equal to 74. So you may see it happen either way. You may see the lower quartile, upper quartile. You may not have to add the numbers in the middle and divide by 2. It may just be a single number in the middle, much like the median was in this case. So it just depends on how it splits up here. Okay, so those numbers make up the 5-number summary: low, lower quartile, median, upper quartile, and high. Now the so-called interquartile range, or IQR, is found by taking the upper quartile minus the lower quartile, Q3 minus Q1. So 74 minus 32.5 is equal to 41.5. They specified the interquartile range as a way of identifying outliers. And the criteria they use is to take Q1 minus 1.5 times the interquartile range, IQR, and the upper quartile, Q3, plus 1.5 times IQR. Any values that fall below or above these would be considered outliers. So in this case, for the lower number, we'd have 32.5 minus 1.5 times 41.5, which is going to be actually a really small number in this case, of negative 29.75. And if we take 74 plus 1.5 times 41.5, we get a pretty big number, 136.25. So in this case, there are no numbers in our set of values below negative 29.75 or above 136.25. That means there are no outliers involved here. Next thing let's do is the standard deviation as the sample standard deviation. Recall the formula goes S is equal to the square root sigma x minus x bar all squared divided by n minus 1. So as we go through here, we have to do this in steps. First step is to take each value x minus the mean x bar. That means for each value, we need to subtract away 54.9. Okie doke. And so that's going to look something like this. We'll have numbers like negative 33.9, negative 24.9, negative 19.9, and so forth. Okay, and then the next part of the formula is to do the subtraction numbers we got after doing that and raise it to the second power. So you have to square each of these values. Okay, and here's what I got out from there. I got numbers like 1149.21, 620.01, and so forth. Okay, so that's the next step. Now, the next part of the formula after doing the subtraction and the squaring is this part here that has the sigma. That means to take the sum. So we need to take the sum of all the values from up above. And if we add up all these numbers, we come out with a pretty big number of 4,177.52. So in our formula, the sample standard deviation would be equal to the square root of 417752. That's the number that goes on top. And then recall that the lowercase letter n stands for the number of values. And there's 9 numbers here in total. So it's kind of like the mean. We have to divide by that number, but in this case we have to subtract 1 away from it. So let's do that here. Divide by 8. And I went ahead and calculated and rounded to the nearest 1 decimal point to get 22.9. Sample standard deviation. Okay, and to finish this up, we're going to create the box plot from our data here. So we need a number line to get started, and in a box plot we start by drawing a box where the lower side of that box is the lower quartile and the higher side of that box and the upper side of the number line would be our upper quartile. So here from 32.5 to 74, I'll box that in. Those are the left and right sides of the box. In the middle of the box, I'm going to put a line where the median is located, 54. And then on each end of that box, I'm going to draw lines extending out to the high value and the low value. This particular table here summarizes for 40 students the number of students to the number of books read. And we're going to create a mean for the number of books read from this information here. Now this is a frequency table. So to do the mean of a frequency table, we have to use the idea of taking the sum of each value times the frequency divided by the sum of all the frequencies. Here written as sigma x times f divided by sigma f. X is going to again refer to the numbers in the first column and the second column being the frequencies. So what we're going to do is take each number divided by the times the frequency. So like 5 times 2. Then we're going to add that with 8 times 3. And then 16 times 4 and 11 times 7 divided by the sum of all the frequencies, 2 plus 3 plus 4 plus 7. On top, that gives us a total of 175 divided by 16, and that's equal to approximately 10.9. So again, that's the average, mean average for the number of books.